Hello children, today we will see what is a series connection and what is a parallel connection. So you will be doing experiments in the lab even, and then how you are connecting components in a series connection and how you are going to connect it in a parallel connection. So here, series connection, the components are arranged end to end. Suppose if I have taken resistors, suppose this is one resistor, the other resistor is connected something like this. Okay, so one end of the resistor is connected to one end of the other resistor, and these ends will go to different components. So if this is R1 and if this is R2, so you can see only one end is connected to one end of the resistors. So as soon as it is given in the numerical, you have to identify. If you see like this, it is series connection. Now in parallel connection, both the ends are connected to both the ends. Suppose this is one resistor and this is another resistor. So you can see here, this end is connected to one end of the second resistor, and the other end of first resistor is also connected to the other end of second resistor. So in this way it is parallel. Now what happens in series connection? If one component fails, the other component also doesn't work. So when one component fails, the circuit is broken and none of the component works. But in parallel, it does not take place like that. So if one component fails, then the other components, they keep working. Now here when you see in series connection, this is most important. When you take potential difference applied, so that is divided across the components. Suppose you have some potential difference, that will be divided across this R1 and across R2 based on their values. Whereas in parallel connection, the potential difference will remain same. Now what happens to the current in series connection? It remains constant. Suppose I is flowing, the I is a symbol for electric current. So if I is flowing, you will say that same amount of current flows through resistor R1 as well as resistor R2. But here it divides. How it divides? It divides as I1 and I2. But the sum of both the currents like I1 and I2 will be equal to total I. So here current is constant throughout the electric circuit, that is in series connection, and in parallel circuit it divides the current through the electrical gadget. Suppose I am talking about the resistors here. Then what is the formula? Here it is the sum of all the resistors given. The resultant resistance in series connection is the sum of all the resistances. So you will just add up Rs equals to R1 plus R2 plus so on and so forth. Therefore, in a combination, you have to see which is the highest resistance. The resultant resistance in series combination will be even more than that highest resistance. So in that way, you can just guess the answer. Then in parallel connection, the reciprocal, you have to be very careful while putting the formula here. The reciprocal of the resultant resistance is equal to the sum of the reciprocals of individual resistances. So here in a combination, see which one is the lowest value of resistance. The resultant resistance in parallel combination will be lesser than that value. So now while doing numericals, these are all very important points. One is you have to know the formula. The other is you have to identify which one is in series connection, which one is in parallel connection. And you have to know like potential difference is divided in series connection and current is divided in parallel connection. So before going to do all the numericals, you just be very, very careful and understand what is series connection and what is a parallel connection. So when once you are thorough with this, you will be able to do numericals, and then questions will come on advantages and disadvantages that we will see in my next video. Thank you.